When we talk about submersible mixing technology in wastewater treatment plants, generally the bulk of the discussion by all of those involved is finding the right size mixer for the application, because they come in different propeller diameters, different speeds, and so forth, and horsepowers, and it's critical to try to find the right size mixer for the specific application. Too much energy, then you're wasting energy if the mixer's overpowered. Too little energy, and then it's not complementing or doing what it needs to do with the process. So that is, a very important part of mixers, selecting the right mixer. Equally important and not so often discussed, or there's a topic of discussion so much, as the position of the mixer, because you can get the right mixer. If it's not positioned properly in the basin, then it can be just as bad as picking the wrong mixer for the application. So with this demonstration, what we want to do here is give you a little bit of an idea as to the importance of positioning. We've got a basin here approximately 24 by 12 by 12 inches high, and with 8 inches of water in it, and a little submersible mixer here that is got a little boat prop on it, and I can adjust the position side to side as well as end to end anywhere in the basin, but we'll, for the purposes here, move it around in various positions and show you the effect on it. We have some little beads at the bottom here that will, given a little bit of help, we'll start moving around, and that's to aid in showing the visualization of where how the flow patterns are, how they develop, how they continue, and so forth, because normally in a wastewater treatment plant you're dealing with sewage, so you can't see. You can only see on the surface. You have no idea what's going on down below. This gives you a little bit better of an idea. I'm not showing you anything here brand new that hasn't been looked into before. The technology is nothing new, but again, this is just to show you the importance of the positioning, because the manufacturer of the mixer is expected to not only recommend the particular type of mixer, the model, but as far as where is the optimum positioning in the basin for the best mixing to occur. So I have the mixer wired to a little 12-volt DC just train transformer basically here, and I can control the speed as well as the direction. Obviously we're going to do a forward thrust on it, so I'm going to run it in that direction there. And so with that, let's get started. I'm going to start out with a position right in the middle. You would think, well, what's the best position for a mixer? Is it dead center of the mixer, in the basin, excuse me? Let's see. Not many people think about that. So we'll put it just off the floor, and we'll straight ahead, and let's get it going. And we'll turn it on to about half power. Got some motion going on there, obviously. As you can probably tell, you may want to come a little bit more overhead.
I can see it.
We've got most of the velocity is down here, concentrated here, down here towards this end. There's a little bit of a heavier, a denser area of the beads there. And one of the purposes of a mixer in wastewater treatment is to not only maximize the contact of the microbes with the water, area to area, surface area, but also to prevent solids from settling out and accumulating on the bottom of the basin. So that would require that the basin has to be drained and cleaned more often, and wastewater treatment plants don't like to have to do that as much as they don't have to. So the purpose of the mixer in this case would be to keep things moving, keep things in suspension, and while we have a generally overall good mix, we've got an area of lower velocity back here on the back side, I'm going to say, and you can see it seems like most of the beads are concentrated only. Most of the motion is only on this half of the basin. So let's go ahead and slide it to the back. And let's try center. What happens there? And we've got Much lower velocity now at this end, although it takes a few seconds oftentimes for the pattern to develop and then stabilize. Definitely not good what you're seeing over here, because this would simulate where they would have accumulation of settled solids. Although it did get stirred up there a little bit, but the indication that there was a point of lower velocity would indicate that that's not the best position for the mixer. Once things settle out, it takes a lot more energy to resuspend them back into the liquid. What if we increase the power? Let's go full power and see what happens. There we go. We do have a little bit more energy down at that end, but we've still got in this corner not a good situation. So yeah, the pattern picked up there a little bit, dispersed it, but I think we're going to have a reoccurrence of what we just saw there. Yep, in the corner. So what if we take it to off center? Let's bring it over this way and put it to one side, straight ahead. You'll notice probably, as you already have, that we're going to get more of a rotational pattern like this. So there are some mixer manufacturers that this is their recommended position for the mixer is back in the corner and straight on like this. But again, this applies. We have to remember that this applies to keeping basins with the ratio of 2.5 to 1 length to width for a single mixer. Once you go above that length to width, and that applies to either the length of width or the depth of the water, you have to have enough area for the energy to be transmitted from where the mixer is. And I'll also point out that you'll notice where most of the mixing occurs is out here, not in the propeller, not in the vicinity, the proximity of the propeller, but as the fluid motion is the jet comes out here and as it expands, this is where most of the mixing takes place, out here. The longer that distance that you have for the mixer jet to develop, the more mixing that you're going to have occur. It doesn't happen at the propeller. All right, so what if we change the angle now? Let's leave it here back here and let's change it to 45 degrees. Yep, 45. All right, what do we got going on? We've got a couple of things going on. We've got a roll here and similar situation with a lower velocity down at this end. Ooh, dead spot here in the corner. What if we change it to, I'm going to guess this would be about 30 degrees. A little bit better. Let's give it a few seconds to develop. Stabilize. All right, so we've got some accumulation, some settling right there in that area there. It's going to move around, but generally. So it's not an as even of a distribution of velocity as we would like. So let's try. So what we're going to do is we're going to move the mixer to 1/4 of the way from the wall of the distance, which 24-inch basin, so 6 inches on center, and then put it at our 30 degrees approximately. and give it a little bit to develop. Okay, so we've got almost everything in suspension. Looks good. This position that you're seeing here, 1/4 inch off, excuse me, a quarter of the way from the end, just off the wall here, and about from anywhere from 15 to 30 degrees, actually closer to 30, is what our standard recommended position is for basins within the ratio of 2.5 to 1 for 1 mixer. There are exceptions. It can be over a little bit more than 2.5 to 1. You need to increase the power, mixing power. But what you're seeing here is our velo recommended positioning, and you can see we've got a good roll coming back. Hardly anything, settled on the bottom, stabilized pattern now. So what this proves, the purpose originally, as I said, is that positioning does matter.